Okay, this is about estimating and approximating square roots. Now, we're going to address the question, how do we determine what the value is of a non-perfect square root? And what do we mean by non-perfect square root? The perfect square root would be something like this, the square root of 36, because we know that 6 times 6 is 36. The answer would be 6 to that when we reduce it. Now, we can also think about it as what a root means. A root means the side measurement of something, or the dimensional measurement of a square. So if we had a square that was a 6 by 6 square, we could see that each side measured 6. So that's also where that comes into play. So we're going to go take a look at non-perfect squares and how that relates. And how do we estimate the value of that, or approximate the value of it, so that we could put it on a number line and see how it relates to other numbers. So let's remember our perfect squares. We know that 1 squared is 1, and 2 squared is 4, and 3 squared is 9, and so on. And we're going to use these to help us to approximate square roots. We're first going to work with the square root of 5. So we're going to take a look here at a square root of 5. And we know that if I squared a number, it would be somewhere between 4 and 9. So we know that our answer is 2 point something. We've just got to figure out what that something is. So we know that this number is between 2 and 3. But we know it's closer to 2, because 4 is closer to 5 than it is to 9. So we know that our answer is going to be between 2 and less than 2.5, because it's closer to 2. So what we're going to do then is bring up a calculator to kind of prove our point here. So let me get a calculator. And we're going to look at what the square root of 5 is. So square root of 5. We get this really long number, 2.236, so on and so forth. Well, let's write it to the nearest thousandth right now and talk about how do we round things to the nearest hundredth. What we do is we look at what's going on in the thousandths place. Because if this number is 5 or more, if it's 5 or more, we're going to round up. In other words, we're going to add 1 to the hundredths. If it's 4 or less, we're going to leave it alone. Okay, so when we take a look at our problem here, 2.236, this 6 means that we've got to round the 4 up. So this will change. This will tell us that this 3 will become 4. So when we want to approximate the square root of 5 to the nearest hundredth, we would say it's 2.24, 2 and 24 hundredths. Okay, we're going to do that again. Got a number here hiding. I've got the square root of 113. So a square root of 113 is going to fall between 100 and 121. So we know the number is going to fall between 10 and 11. So that means it's going to be 10 point something. It is going to be closer to 11 than it is to 10, because it's 13 away from 100 and only 8 away from 121. So we know it's more than 10 and a half. And again, we're going to pull our calculator up, and we're going to take the square root of 13. And we're going to round it to the nearest hundredth, so we're going to stop at the 3. So it'll be 10.63. We'll do it one more time here with the square root of 80. And when we look at the square root of 80, it's going to fall between these two numbers, 64 and 81. So it's going to be between 8 and 9. But we know it's closer to 9 because it's almost 9, isn't it? So it's going to be 8 point something, and it's probably going to be a high number here, definitely more than 8. So let's take a look at what that's going to be. So the square root of 80 and 8.94 is where we end up. And so this is teaching us how to use a calculator, how to round, and we could have estimated that it was pretty close to that as well. So if we were ever given some options, we can kind of narrow it down. But what happens if you don't have a calculator? What's another way that we can find a true value of a square root that's not a perfect square root? So let's take the number square root of 10. Now we know, if we follow the same pattern we just did a moment ago, finding out what it's between, we know it's between here. It's going to be somewhere between 3 and 4, and it's going to be closer to 3. We know that. So if we were to write this in terms of a fraction, it's going to be 3 and some fraction going on. So we're going to use some graph paper here to help us to show how to write this fraction without the use of a calculator. So 3, we see, is 9 squares almost, right? So the squares. We know that if we take 3 squares and 3 squares, a 3 by 3, we will get 9 squares filled in here. Okay, but we know the next one will be, we need one more though, don't we? We need to get 10. So the next size square up is 4. So if I build a 4 by 4 square, we can see what more is added to it, what fraction will add to it. We know we need one more, and it's 1 out of 1, 2, 3, 4, 5, 6, 7. So this is going to be our approximation, 3 and 1/7. Now I'm going to prove to you that 3 and 1/7 is probably within a couple hundredths of our answer. So let me clear this here. Clear it up here. Let's do 1 divided by 7 first, and show that that's 0.1428. So we'll say 0.143 just for discussion's sake. 3.143. So we know the 3 is the whole number out front. So we're saying that if we use the calculator to find the square root of 10, we're going to say it's approximately 3.143. Now let's find out what the square root of 10 is and see how good our little diagramming is to find the right answer. So the square root of 10 is 3.16. So it's not too bad. We're a couple hundredths off, but that's a pretty good approximation without a calculator. Let's try it again. Here we have the square root of 27. Again, we know that that's going to be between 5 and 6. So we're going to build a 5 by 5 square. And we know that that's 25 pieces in there. To get to the next size square, it's going to be a 6 by 6. So we're going to draw around the outside to make it a 6 by 6. Now if I have 25 and I need 27, I know that I need to add 2 more. So going back, we know it's going to be between 5 and 6. It's going to be closer to 5. So we know it's less than 5.5. We have 2 extra pieces here, so that 2 is going to go on top, and it's out of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So 5 and 2/11 is going to be our mixed number approximation of what the square root of 27 is. Again, we're going to test it with our calculator. We're going to do 2 divided by 11. That gives us 0.18 repeating. So we know that that's going to be approximately 5.18. Let's use our calculator again to find out, hey, what is the square root of 27? How close did we come to it? Not too bad, 5.196. So very, very close. Again, 100th off. We'll try it one more time. One more example. We're going to do the square root of 50. We can find the square root of 50 is here between 7 and 8. Closer to 7 though, isn't it? So we know it's going to be 7 and something going on here. We also know that it's going to be very close to 7, so it's going to be a really small number. It's way less than half, probably less than a quarter. So again, we're going to build our 7 by 7 square. Okay, and that gives us 49 squares. And we know that the outside edge here that I have drawn is our next largest size up, the 8 by 8. Now if we have 49 and I need one more to make 50, so I know my fraction will be 1 out of whatever this whole extra add-on is. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 13, 14, out of 15. Now, there is a shortcut to this without drawing everything. We can use this number line that I just gave you to be able to do that as well. Let me move this over so I can show you how this works. Again, we're taking a look at the square root of 50. We know that it's close, it's above 7, so we know we're going to be 7. It is 1 more than 49, so there's that 1. And the difference between 49 and 64 is 15. So we can kind of do it just by looking at it as well without drawing it. We can approximate it. Hopefully this helps you in estimating and approximating square roots.